Hey, it's Whitney, aka Shapespeare. We're going to learn about how to make these 3D printable models from digital elevation data. So to start with, you have to get some data to work with. This is the easiest source if you're living in the United States. This is the national map, nationalmap.gov. It works kind of like Google Map. You can zoom in and out on areas using your scroll wheel and pick whatever it is that you want to model. In this case, we're going to pick a great big mountain, Mount Rainier, a good choice. And there it is right there. It'll make a nice 3D printed model when we're done. Okay, so we zoom in on it till we can see the mountain the way we want it. Then click this button here, which creates a bounding box. And circle the area that we want. And this menu pops up, and check that we want to download elevation data. Click Next. And now you have choices of different types of elevation data, different file formats, and different resolutions. The highest resolution that you can get on this system is 9th arcsecond, which is equivalent to a resolution of about 9 feet. We're not going to use those because the files are a little bit harder to work with. The IMG files are a little bit harder to work with than the other ones. And also these tiles are so small that in order to actually capture the whole mountain, we'd have to put together a couple of different tiles. So we're going to work with 3rd arcsecond, which is a little bit lower resolution, but it'll work great for our purposes. Grid float is a good choice. Art grid works just about the same. Check that box saying you want to download that one and click Next. And it adds it to your shopping cart. Then you click Checkout and you enter your email address and place the order. And if you're lucky, several minutes or several hours later, you get a link emailed to you which tells you where to go to pick up your data. Once you have that, I'm not going to make you wait for the download. But once you have that and you unzip it, you end up with a file like this. Now you can see there's lots of different files in here, and they all have some purpose, although we may not need them all. I don't know which ones we do or don't need, so let's keep them all, and keep them all together in the same folder is important. But the one we're mostly interested in is the big one here, which has all the data in it. Okay, you can see that one's dramatically bigger than the rest of the files. So in order to open this type of data, we need a program called QGIS, which is a open source, free geographic information systems program. We are going to click on this level here after we've opened it, and open up a menu and find that big file, and we're going to import that big file, and there you have it. This is a digital elevation model. You can see the dark areas are the lower terrain, the mountain peaks are the higher areas. We're going to zoom in on this one. Oops, not quite that far, because that is our mountain. Now you notice it's sort of burned out here. It's all white, and what's happening is this is a 32-bit TIFF image, so it has higher bit depth than we can display on our screen. But in a minute, you'll see we'll fix that. So if we go to the raster menu, extraction, and grab the clipper tool, and drag this over to the side so we can see what we're doing. Make sure that your data layer is selected here. If you have multiple data layers, make sure you're selected for the one you want to be extracting from. select here, and we're going to create a output file for it. And let's see. We're going to call it Rainier.tiff. And we're going to replace that. Okay, so we're going to output our data to Rainier.tiff. Make sure you add the .tif at the end of it, because the program that's the next step along the work chain here won't know how to deal with it if you don't. Okay, now let's use our box and highlight our mountaintop there. That looks good. If we're satisfied with what we've chosen, then click OK. And click OK there and OK there, and close that. And now you can see a couple things. First of all, we're a little bit off center on the mountain. If we were gonna be making one of these models that we wanted to print, we might want to make it a little bit tighter, frame it up a little bit nicer. But you can also see that this box here is now optimized so that the darkest value here and the lightest value here are only with reference to this frame instead of the big image as a whole. So you can see a lot more of the data here. Now, we've already saved this file as part of the extraction process, so we don't need to do anything else in this application, and we will move on to the next one. Okay, the next step in our process uses a program called 3DEM. Now, it's a free open source program. It's been around for a long time. It's not really supported anymore, but it does what we need it to do. We're going to input a TIFF file, so select like that, and a menu comes up, and we're going to select Rainier.tiff, which we saved in our first program, and we bring that in, and this sort of gives us a view, a shaded hillside view of what we're looking at. We don't really need to do anything in this program except to save it as a DEM, which is just a different format for that data. So we save it as Rainier.dem. Once again, make sure you put the file type on there. And we'll be done with that in a second. And that's all we need Rainier. That's all we need 3DEM to do. And the next step moving along is a program called AccuTrans 3D. Now this is the only program we're going to use here which is not freeware. This is actual commercial software, although it's available on very reasonable terms. It's basically on the honor system. If you use it, send the guy the $20 he asks for. I think you'll agree it's more than worth it. If you do at least one of these models, you'll see it's a marvelous program. But it's a little bit quirky. I don't think it's supported anymore, but say it works for what we want to do. Okay, so we're going to open DEM as USGS 1 degree ASCII DEM, and we're going to open our file and give it a second or two to process. We're dealing with pretty big files here, so they do take some time. And here we see it's starting to look like a mountain. We've got this sort of funny false color view of it, but we can do a couple of things here. If we go in the top view, you can see there's our mountain. Now before, we noticed that we were a little bit off center, and we can actually fix that here. If we go into region and hit N for north, and if we click about there on the northern boundary, click W for west, and E for east. East is a little bit too tight, so we hit CE to clear east, then hit E again, and that's a little bit better. So now we have trimmed it. It's probably better to trim it in QGIS because it handles large data sets better than AccuTrans does. But if you end up with a file in AccuTrans, you can still trim things. Now, we're going to take this and on the DEM menu, convert to 3D, less water. And this will show us the number of vertices and the number of polys that we have in this data set we've brought in. So at a vertex interval of 1, which is saying we're going to take every vertex in this model, we would end up with 4.7 million polys. That's a little bit more than my computer will handle happily. You guys don't want to sit here and watch it try and churn that data. If you got a super fast workstation, maybe you could handle that, but I can't. So clicking down to a vertex interval of 2, that means we're taking every other vertex. We're getting down to 600,000 vertices, or 1.1 million triangles. That's the sort of file I typically work with if I'm making a model, to put on the Thingiverse or something to print. It's probably more detailed than you really need, and it does slow the computer down a little bit. So because I'm taping, I am going to knock this down further to taking 1 out of every 4 vertices, and that'll speed things up a bit. We won't have to sit here and wait for the computer so much. Okay, and that's all done. Now you can see this is our mountain that we've got here. First thing we're going to do is go up to the Tools menu, and it's a little bit slow here. So going up to the Tools menu, and we're going to Adjust Object, and this model here is brought into this program at life size. So you notice our coordinates are in the 23,000 range. That's basically 23 kilometers is what we're looking at there. A little bit bigger than we want for 3D printer, so we're going to scale it down. If you have a 3D printer that can print something 23 kilometers long, go for it, but most of us are going to have to scale things down. So we're going to scale it down. It's kind of funny, you have to input a different scale value for each axis and then click scale, and we're still a little bit on the big side, so let's click scale again, and that's better. Okay, so now we're in the range of 230 and 140. That's more reasonable size for a 3D printer. Another thing we're going to do here is I like my models that I'm going to 3D print, I like them to be centered. So I'm going to click Set Minimum to 0, 0, 0, and then Center XY Z no change. And the other thing is that there's some programs are Y-axis up, and some programs are Z-axis up. We're going to take this into Blender next and tweak it a little bit. So we're going to flip it, just like flip it 90 degrees so that instead of being Y-axis up, it will be Z-axis up when we get it into Blender. And there you can see that's the view of our mountain as after we've flipped it. Now we are going to save as and save as Rainier.stl, because the file that we are pulling out of here is a STL file. And the last program we're going to use in this workflow is Blender. If you're not familiar with Blender, it's an open source 3D graphics program. It's originally designed for doing film animation and special effects, but it works really well for 3D printing applications as well. So we're going to go to the File menu, and import our STL. And give this just a couple seconds to import. It's a pretty good size mesh. Blender is really good at handling really big complex meshes because that's what 3D graphics is all about. So if you scroll back with your mouse wheel, you can bring it all into view. Click with your center wheel. Let's click on your middle mouse button or your wheel and pan around, and you can see the whole mountain. All right. Now, we can't print this because it's just a top skin here. We need to make it into a full mountain, into a full printable model. So we're going to hit 7 to get to our top view, and then go up here and add a cube. I'm going to specify our cube with a radius of 50. That'll get us started. Going to go here with these different options down here are your, they call them transformation manipulators. That's your translate manipulator, your rotate manipulator, and your scale manipulator. Basically, this allows you to move objects back and forth. This lets you rotate them. This lets you resize them. It's a fairly easy way to get at the tools in Blender. There's also keyboard shortcuts that you can use, and I recommend the keyboard shortcuts if you're doing a lot of work on it. But so now we've got a cube. Now everything that's above this surface will go away. Everything that's below this surface will become our model. Now, having said that, we don't want to have all this extra material down there because that would just waste a lot of filament and take a long time to print. So we drag this up so it has a little bit of a base under our model, but not a huge amount. Okay, now this up here in the upper right hand corner is called the outliner view. Very handy. It allows you to select the different objects. You can also hide them. So in this case we could hide the cube view and just look at Rainier. But we actually want the cube back on, and we're going to select the cube, and we're going to go down to here and scroll around with our scroll wheel until we get the modifiers menu. Looks like a little wrench. We're going to say add modifier. We're going to choose a Boolean modifier, and we're going to say give me a Boolean intersect between the cube and our top surface. And this will take a couple of seconds to cook. The bigger your file, obviously, the longer it takes. If you look up here on this part of the menu bar, that shows you how big your file is that you're working with right now. In this case, we have 150,000 vertices, or about 300,000 polys. That's nothing for Blender. I routinely run 1 million vertexes. It just takes longer. Okay, so here we go. Now we've started our modifier, but we haven't applied it. We haven't finalized it. I'm going to do that right now. You could theoretically just leave that modifier hanging there without applying it and go and do other stuff, but every other operation that you do, it has to recalculate the modifier. And since, you know, this large mesh Boolean takes a couple of seconds to do the modifier on, we just want to apply it, do all the calculations once, and be done with it. But if you're working with a smaller model, you can leave your modifiers open and go back and change them when you want to. Okay, so it looks kind of funny and speckly like that. That's because we have the top skin is also on. If we turn that off, we can see that is our model. Okay, so if we want to get that ready for 3D printing, we can check the dimensions here and see if that's going to fit on our printer, which that looks pretty good, about the right size. Then we can go up to the File menu and export the STL, and in this case I'm just going to save it right back over Rainier. Now, there is an option in AccuTrans. I tried to demo for you earlier, but AccuTrans just was not behaving itself with Cam Studio running. But basically, the process of turning an object into a three-dimensional form like this can also be done in AccuTrans. They call it's a toolbox option called Extrude Pseudo 2D Surface. Now I'm going to show you why I don't like that option in AccuTrans, although you can use it and it does work just fine, and with smaller models it's not a problem. If you look here, for instance, this will show you exactly right here why I don't like it. This is the one that we just finished and saved. It's 13.7 megabytes. The AccuTrans version of essentially the same model is 19 megabytes because it's using a very inefficient algorithm to solidify the model. I'll show you guys what that looks like. We're going to open that one there. We can have them both on screen to compare them. I think it's better to do it in Blender, although it is a little bit more work. Okay, so let's see. We'll go into the top view and drag this guy off to the side. Okay, so slightly different crop on it because AccuTrans was crashing on me and I had to go back and recrop it, but you'll get the idea. So if we look at the bottom side of it, and we're going to go into edit mode here. Let's center on that. We're going to go into edit mode, and this shows us that we have one square that is our base here, basically one polygon. That is the bottom of our model here. That's the one we did in Blender. And that's how it should be. You've got a rectangle. You don't need more than, one rectangle or two triangles, depending on, if you're using triangles. But that's all the data you really need to define that face. Now, we're going to look at the way AccuTrans does it. Okay, you see something different here? AccuTrans takes every vertex, every polygon from the top surface and projects it onto the bottom surface. So the entire bottom surface is made up of a mesh that exactly matches the top surface, which is basically a ridiculous waste of data. You've got thousands and thousands of data points there that are completely unnecessary. Now, that said, your 3D printer and your slicer software probably don't care. You could send either of these files to them and you really wouldn't notice a difference in performance. Where you would notice a difference is if you were uploading to a service like Shapeways, which has a limit to how big a file can be, or a limit to how many vertices or how many polys a file can have. You don't want to waste your polys on the bottom of your element there. It just doesn't make sense. So learn to do it with Booleans in Blender is my advice. Okay. So that's pretty much all there is to making 3D models like this with your basic digital elevation data. If you join me next time, I'll be talking about how to do the same sort of thing with what's called LiDAR data, which is just ridiculously detailed scans. These are made to a resolution of about 30 feet, so they're good for picking up mountains and stuff. LiDAR data you can get down to a resolution of about 6 or 9 inches. You can pick out individual buildings. You can see cars and parking lots. It's really marvelous, marvelous fun. So that's what I'll be talking about in the next video. So I hope you join me. Thank you. And if you want more information on this process, You'll find a complete description on my blog at www.3dprintedfuture.com. It gives you a complete description of all the steps, starting from the beginning. It gives you links to download all the programs and everything you need to follow along.